Hi everyone, you're welcome to my YouTube channel. Up until now, we have been dealing with functional programming, but from today's video and henceforth, we will be discussing object-oriented programming. I did a short video, which I will leave at the end of this video, on everything in Python is an object. So now, like we did when we were discussing functional programming, we defined our function with the word dev. But in object-oriented programming, we will define our classes with the keyword class. Now, you understand fully well that object-oriented programming makes our code modular. It makes it easy for us to share our codes, and also it makes code development very, very elegant in the sense that you can easily reuse your code without having to bother about rewriting the methods or the functions in that classes. You can also inherit the parent class and easily add additional functionality to your existing class. And that's why object-oriented programming is a must know for any programmer. But we'll start with a very basic explanation and a plain template, very simple template. For example, I will start with here, I have a class which I call animals. And right inside this class animals, I have name as cat and then speak as meow. Now, what I have put in here are the attributes of that class. Now, these precisely are referred to as what now as the class attributes. Now, if we run this and then I want to do something here, let's check the type of the class animals. So what do? We say print type and then we enter the class name. If we run this cell, what does it give us? It gives us that the class is what now? The type is what? Is class. Okay, what about if we instantiate the class and we do that? Remember, when we write functions, we always what now passing the parameters to the function using the parentheses. Likewise, in classes too, when we write our classes, I would show you how we pass in the parameters, which is like instantiating the class. But we can always call the class with the parentheses. Okay, to a password now to pass in the parameters or the argument to the class. If we print this, what does it give to us? No, it tells us there is a class with what now? With the name main. So that's the main class. Okay, now let's do something else here. Let's instantiate this class and try to assess the attributes, okay, of that class, which is the class attributes. So I'll instantiate the class with C equals animals, and then I want to print the the name. So I'll do C dot name, and then I will print again C dot speak. Okay, what will this give us? It, of course, the class is instantiated as C, and then C dot name can access the class attribute, which is a name cat, and the speak meow. Now, this is just the basic form. Now, let's move here to now, instantiating a class and passing in the right class attribute. Now, for every class, like we said just now, that it begins with the keyword class, and then we pass in the class name. Okay, and then we have here the class name as fruits. To instantiate the class, okay, in other words, to be able to pass in the passing parameters, okay, to the class, what do? We define, okay, a method def. Remember, def is used to define a function, right? In a functional programming that we looked at. But here to define every method, okay, which is a function. Okay, every method of a class is a function. Now we want to define the init method of this class. In other words, instantiate this class so as we can take in parameters. So we start with dev and the the donder, which is the donder method, double underscore init double underscore. The first parameter after that is self. For every class, there is always a self associated with that class. In other words, we can always call a class with self. So we have self, and then you can pass in other parameters, name, price, and quantity. What we do next, we go right inside the init method and call self.name equals name, self.price equals price, self.quantity equals quantity. I will explain why we're passing in the self, and you can see what how we're able to access this name just like we did with the animal class. And then I will proceed again to define another method. This method is simply a function. So, in other words, to add functionality to a class, okay, we define a method which is in a plain or functional programming paradigm functions. So here I want total amount, and the total amount is not taking any parameters, okay, only self, okay, which calls the class fruit. So, and then it returns self.price multiplied by self.quantity. Now, so first, let's define the first fruit, apple, which is fruit. I'm passing the name of the fruit, apple. Price is $30, and quantity is 100. Define another fruit, banana. Banana is the name, the price is 50, and the quantity is 200. Now, to by passing in this, we have instantiated two classes, apple and fruit. So we can print apple.name. Because we have called self.name, we can access that instance, okay, which is name of the class, as well as the price, as well as the quantity. So if we run this cell, first of all, fruits, we have in a namespace, and we run this, what do we have? It prints the name as apple and returns the total amount. Mind you, the total amount here is the method, okay, which takes no parameter, because the first parameter of every method, okay, every method in a class, okay, is self. So we can query it this way, right? I will explain something. If you don't want to, we want to just call or query by just calling the method directly, apple dot total amount without the parentheses. There is a way we can do that. Likewise, we can do the same here. Also print banana, which is the second fruit, banana dot name, and then we can print dot name. We can print also. We can print banana dot total amount. Okay, and what would that yield? It returns apple, banana, and the total amount of banana. You can format your print statement. All of that, lies within your reach. We have done that if you watch all my previous video. Next, we'll proceed to talk about various class methods. Okay, we have looked at the first one, which is what now? The instance method. Okay, in other words, the init method, the dundal underscore init double underscore, right? The, the other ones we're going to look at here briefly is the static method, the class method, and the property. Remember when we talked about closures? I will also leave that video at the end of this video. You can watch that when we talked about closures and decorators. What this method simply do is to decorate, okay, the method in that class. So we use the static method, class method, and property to do what? To decorate a method in that class. For example, we use that to decorate. We can decorate this total amount. Now, by static method, what do we mean? If we have a class, okay, and we want to have a function that we can, an external function that we can call without instantiating that class. In other words, without passing parameters to that class, what we simply do is to call that the static method, decorate that method with the static method. Now, the static method is isolated from the class itself. And how do we decorate that? We simply use at static method. So here I call a class D and I call a static method and I define a function f of x which returns 10 times x. Now, what happens here is that this static method can be called without instantiating the class. Ideally, we should instantiate the class with the parenthesis and then passing the input parameter. But because it's a static method, we can access this function by just calling the class name dot the, the method itself. For example, if we run this, it returns 30. Likewise, if I instantiate this class and then, of course, because it has no init method, and call again, it will return the same answer. So without instantiating the class or with instantiating the class, we can easily call the static method. So it has that functionality. So if you have a method which you want to call outside the class, you simply decorate it with the static method. So that's what I've also shown here. So the first one here is to access it without instantiating the class. Second one by also instantiating the class. The next we'll look at is class method. The class method, instead of taking, remember that when we looked at the static method, okay, because the static method, you know, looks at the external functionality of that method implemented in that class. It does not take the self, but the class method okay, starts with the keyword class. Now, what is class method? Whenever we have class attributes, let's go back to our first example here. You see, if you have a class where you not have something like this name and speak inside the class before defining or instant defining the init method, this attribute becomes class attribute. The only way we can access them is to what? Use the class method. Okay, and then we call at class method, define the function, this class method interacts with the class, and that's why it begins with CLS class and then passing the variable. And then you can return the class method, you know, here I want to return the class name because C dot double underscore qual name returns the qualified name of the class and also return x times x. Now, so if I do this, run this, uh, I can call the class method as well without instantiating the class. So I have e.f of 3 and that will return first the class name e and then return 9. I can also call that class method by using instantiating it as well and then dot f of 3 and what would that return? To return the same result. Now, I can as well decorate the class, okay, using two different methods. Here I'm decorating this class G with a class method and also with a property. Now, what is a property? If I want to access every function in a class the same way I access the class attributes, okay, without the parentheses, all I need to do is to decorate that method or that function in the class with as with the property method. So here I'm decorating twice. I have class method, property, and I define a dunder method doc, which calls because I'm using a class method. The first um, um, keyword here is CLS class. Of course, it takes no input value or no parameters, and I'll return a doc for what? Just say a doc, okay, or documentation, a documentation for what? For this class. So I will use cls.call name to call to get this class name. Okay, by running this and then calling, you can see here I'm not instantiating the class and I call g dot, it gives me a documentation for G. Now let's take this method here and I will use that to explain the property method, this example here. I'll go back and come down here, and I paste here. Okay. Now, if I have like a constant parameter which doesn't change in the class, I can fix it. Okay. For example, let's say the quantity, I have the quantity is fixed to 200, is constant, right? And I'll simply make this quantity a class attribute. Now, and here I will remove the quantity from the init method so that what I have is simply this. Okay. Now I'll come here and I want, let's first of all do this. What I'll do is to run this, and then I'll call another, let's say A, we'll call a class of fruits. The name, the name, the name is apple. Okay, and what's the price? The price is 30. Okay. Now let's return. Let me print a dot. Let's get the quantity. I can access that class attribute that way. If I run this, what do I have? It gives me the quantity. Now, in the same vein, I can likewise get the total amount, okay, by simply, because it returns, I can print a dot total amount, right? Printing that. It gives me the total amount. You can see that by doing this, I can always access this class attributes right inside the class. Now, if I want to call the total amount, since it takes no input and just call a dot total amount, all I need to do is to come here and decorate this class with at property. So that if you run this again, I can get a dot fruit and I can call a dot amount. This is the usefulness of the property decorator. So I think I've explained that on property. Here also I'm demonstrating that here I have a class F and I have an init method instantiating a class F dot name is name, and property I want to get the name of the class. Now to get the name of this class, to get name I can simply call, okay, call print self dot name. Okay, so if we run this class now and then I have F, instantiate the class and then get name, what will it return? To return mango. Next, if I have, I can create an immutable um, class attributes by simply using the double underscore slots, double underscore, and then I have, a tuple of underscore department and then name. Now I will come here, instantiate this class with department and name. I have self dot underscore department equals depth, self dot underscore name equals name. Here, in other programming language, we oftentimes this single uh, prevailing underscore is used to make that variable, okay, not accessible externally from that class, okay, and that's what we call the private member. Okay, we have public member and private member, or public attributes and private attributes. So what happens here is that I'll also give a detailed explanation of this in the next in my next video, which will be the part 2. So I have self dot underscore depth, and then here I define a property method, okay, that gets what gets department, takes no parameter, and it returns self dot underscore depth, and that's what get name and returns self dot name. Okay, we run this. I can query this class to say the mark is immutable, and then passing the name is Botany, and what no, the department comes first. That's why our department is Botany and the name of the student is Mark Slim, right? I can query mark.get what get department and mark.get department. And what I want to do here is that I want to change by setting the department to fishery. Let's see if that is possible. First, let's pick mark.get department. What do we get? It returns botany. But if I try to set the department of fishery, it throws up, an attribute error. Okay, it means get department of immutable object has no setter. Okay, by making this allocating this slot here, I automatically makes any of these class attributes, okay, immutable, which means you cannot change it. And so I would end this video here. In the next video, I will go deeper, more into object-oriented programming and illustrate more examples with this. If you find this video interesting, please give it a like, share this video with your friends and colleagues. And if you are watching my video and you have not subscribed to my channel, please do subscribe to my channel and also click the notification bell to get notified whenever I drop new videos. Until then, I will see you in my next video.